Here's a demonstration of my project. So what we have is we have the outdoor temperature and we have an indoor temperature reading. My outdoor temperature reading is around 75, 80 degrees, but it keeps fluctuating, so keep that in mind. But yeah, so what we have, indoor temperature is controlled by my potentiometer. Outdoor temperature is controlled by my LM35, which is reading my house. So with that being said, let's see how it works. So we have a display here that displays my temperature. My indoor temp, which is controlled by my potentiometer, is reading about 34 degrees. That means it's cold in the house. It should be blue. If we turn it up, okay, actually first, so now every 15 seconds my monitor will switch between outdoor and indoor temp. So you can see in my house it's around 78 degrees. We can also show that my button switches between the two if I press it. You can see I can switch between the two. Yeah, see. So I have a button, so if you want to check yourself between the two, you can. Every 15 seconds this should just alternate on its own. So we can look. Yep, there you go, 15 seconds. And the temperature is updating, so as you can see, it's updating on its own and displaying. So now what I want to show is that we have this window right here. So whenever the window, if the outdoor temperature is below 80 degrees like it's saying, and my indoor temperature controlled by this is above 85, then this window should open. And it should display hot. We have to wait for my outdoor to go below 80. My outdoor. Yeah, let's read it. Let's see. Yeah, see, it's above right now. Oh, let me switch back. Oh yeah. So we wait till it goes below. There, see, the window is now open. We can close the window whenever the temperature indoor is colder than the outside because we want to preserve our AC. And yeah, so this light blink screen every 3 seconds to show that the monitor is working. And yeah, so everything's set up. We have an LCD screen, we have a potentiometer, we have an LM35, we have a button, my window, some LED. Let me turn it to red so you can see. We have an LED lights set up. Red for hot, blue for cold, green for medium / showing that this is working. It also has my like wires and resistors and whatnot hooked up to my ports, and yeah, my analogs, 5 voltage, and my wire connected to my PC. Yeah, pretty cool. So here's the code part of my project. I'm gonna explain a little breakdown of it. So what we have is some libraries for the components of the code, for the LCD screen, for the LM35 temperature readings, for the servo. We have our LED set, we have our LM35 sensor value set to the pins, whatnot. The value variables, we have potentiometers, similar things. We have the button set up, we have its initial status at low, set to pin 2, all this. We have an update counter, so every 15 seconds the LCD should display change, but these are like variables and whatnot. My servo, so I can call and create the servo object. LCD setup, here's some things. I have a contrast set so that my readings LCD can read very well. I have my loops, that's all within my void setup. We have within my loop, we have the temperature reading conversions from the value to Celsius, and then from Celsius to Fahrenheit, and I did that for both. I'm reading in Fahrenheit. So my potentiometer, similar deal. This one's controlled by the voltage, so when I turn it, this will change. the value of the Fahrenheit back and forth, so low and high. I have some if statements. So if the indoor temperature is above 80, that means that it's hot, and so turn on the red LED, and then AC will turn on. If the indoor is less than 65, it's very cold, so turn on the blue light. And the indoor temperature is, and then turn on the heater. We have the servo motor window, so if the indoor temperature is above 85 degrees and at the same time outside is below 80 degrees, we want the window to open so we can let out some of the heat. If the indoor temperature is colder than the outside or less than, then we want to close the window because we want to preserve the cold, the AC. So now the button. So the button, I set it up that's where there's a last state and a current state. What it does is it will compare a last state and low state depending on how it's set up. If they're opposite of each other at any time, then these will activate. So if the status is low, it'll switch to high. If the status is high, it'll switch to low, so that when I press the button, because the status will go through this little if statement, and then if the status equals this, it'll read indoor. The status reads like high, it will go to the outdoor. And so when I press the button, it will pretty much switch it, and that's what's going on. So when I press the button, it will switch the state, the status, and it will go through here, and it'll be the opposite version. So if I'm indoor and I press the button, it'll go to outdoor. If it's reading outdoor and I press the button, it'll go to indoor. There's a delay of 3,000 for the green light's heartbeat every 3 seconds. We have a counter. This counter counts up to 15 seconds. It iterates by 1 every 3 seconds because there's a delay. So if it goes up to 5, that means 15 total seconds have passed. If we do the counter modulus 5 and there's no remainder, that means it's been a interval of 5 seconds. So the status will be flipped, and then it will read the temperature depending on the status. So if it's low, indoor temp; if it's high, the outdoor temp. So pretty much every 15 seconds it will alternate what it's reading. And then here's a little like heartbeat signal. So here's my green LED. It'll be high. After 50 seconds, it'll be low. It'll be a real quick switch, and then when it loops back, it'll be high again, and then real quick low, and it blinks like real quick. High, low, blink, low, high, blink, low. And so yeah, that's my code.